Section 1.6, Part 2, Division with the Traditional Algorithm. During the first video in Section 1.6, I talked about three different methods of division: the circle method, the sidebar method, and the traditional algorithm method. While both the circle method and the sidebar method make a lot of sense to many people, they are at times not the most efficient. For that reason, I find that a lot of people prefer to use the traditional algorithm method. Once again, it doesn't matter to me which method you choose, as long as you get the problem correct and it makes sense to you. In this video, I will spend a little more time talking about the traditional algorithm and give you some additional practice problems to do. You will notice that I will be doing them on graph paper. I have found that the reason many people struggle with the traditional algorithm is because they are not lining up numbers correctly, which then causes difficulty in getting the correct answer. Before I begin, though, I have a question for you. Does McDonald's sell cheeseburgers? Does McDonald's sell cheeseburgers is an easy way to remember the 5 steps that you need to follow when you are going through and using the traditional algorithm. The D in does stands for division. So the very first thing you're going to do is you are going to divide. The M stands for multiplication. That's the second step. So first division, then multiplication. The S in cell stands for subtract. The fourth step, the C, stands for check. And then the final step, the B, stands for bring down. So I will be talking about these 5 different steps: divide, multiplication or multiply, subtract, check, and bring down as we go through the traditional algorithm. So we're going to go through and we are going to divide 863 by 5 using the 5 steps that I have listed here: divide, multiply, subtract, check, bring down. As you go through and do this, 863 divided by 5, the very first thing I'm going to do is I'm going to take a look at the 8. I'm going to be looking at this number here from left to right. And I'm going to say 8 divided by 5 is what? Oftentimes people say 5 goes into 8 how many times? Well, 5 will go into 8 one time. So I'm going to put a 1 up above the 8. Now I'm going to go through my second step. My second step is to multiply. And I'm going to multiply 5 multiplied by 1. 5 times 1 is 5. And now I'm into my third step, which is subtract. 8 subtract 5 gives me 3. My fourth step says to check. And by checking, you need to make sure that the answer that you just have, this 3 right here, it has to be less than the divisor. And 3 is less than 5. If that number were greater than the divisor, that would mean that when you first did the division, you said to yourself, how many sets of 5 are there in 8? When you did that, then the number that you got should have been greater than that. In this case, it does not work that way. So my check is A-OK. 3 is less than 5. Next, I'm going to bring down the next number. I'm only going to bring down one number at a time. Now I'm going to go back up to the top again, and I'm going to start the process over again. I this time have 36, and I need to have 36 divided by 5. So I'm saying, how many sets of 5 are there in 36? So I'm going to go through and I'm thinking about my multiplication tables for this, and I'm going to put them over here to the side. Oftentimes I might want to do this just to kind of help me out a little bit as I go through. This is all 5 times all these numbers. Sometimes this helps me as I go through to figure out what my division, that first step, needs to be. 5 goes into 36 how many times? Well, I can see 5 goes into 36 7 times because that's closest to that 36. So I'm going to put a 7 up top. Now it's very important that that 7 goes in that particular space above the 6 because things have to line up. Now I'm going to go through and I'm going to multiply again. 5 times 7. 5 times 7 gives me 35. And I'm into my third step. I'm going to subtract. 36 minus 35 gives me 1. And I'm going to bring down my next number. I only bring down one number at a time. And now I'm back up to the top again. 13 divided by 5, how many times does 5 go into 13? I see by looking over here, it goes in there twice. So I'm going to put a 2 up top, and then I'm going to multiply. 5 times 2 gives me 10. I subtract, I get 3. I check again, and 3 is less than 5. So it looks like I am done, and I am at this particular point because I cannot bring down any other number. So the answer to this is 172, and we oftentimes say it has a remainder of 3. One other thing I want to mention in this problem, when you get done doing these problems, you can always check these problems, and you can check these problems by going through that process of multiplication. If I want to go through and check these problems, let me clear off some space here by getting rid of this. I am going to go through and I am just going to check this by multiplication. I know that 863 divided by 5 gives me 172 with a remainder of 3. If you think back to the circle method, that would mean that I would have 172 things in each one of those 5 groups. So that means that if I go through and if I multiply 172 times 5 and then add that remainder, I have to end up with that 863 that I have right here. So I'm going to go through and do that, 172 times 5. And I'm going to use the traditional method of multiplying. When I do that, 5 times 2 gives me 10. I put down the 0, regroup the 1. 5 times 7 is 35, plus 1 is 36. Put down the 6, regroup the 3. 5 times 1 is 5, plus 3 gives me 8. I get 860, and then I need to add the remainder. Add the remainder of 3, I end up with 863. So that is one way to go through and check. I can multiply the divisor by the quotient, add the remainder, and I should get the dividend, in this case the 863. I'm going to do another problem here, but in this one I am purposely going to make a mistake because I want you to see something. The very first thing I need to do is I need to take a look at this 2, and I'm working from left to right with my dividend. And I'm saying to myself, how many sets of 7 are there in 2? Well, there aren't any. So in this particular case, I now, instead of just looking at the 2, I need to look at the entire number, the 29. And once again, I'm going to ask myself the same question. How many sets of 7 are there in 29? Well, let's say I go through my 7s and I say, well, let's see, I think 7 times 3, or I'm going to go through and figure that out. How many sets of 7 are there in 29? I think there's 3. And then I'm going to multiply. 7 times 3 gives me 21. And now I go through and I subtract. This is where you need to be careful because my fourth step is to check. And when I subtracted, this number right here is more than the divisor of 7. That tells me that I made a mistake. And 29 divided by 7, 7 goes into 29 more than 3 times. So what I'm going to do is I'm going to erase what I have done right now, and I'm going to rethink that. And as I go through and rethink that, oh yes, 7 goes into 29 actually 4 times. So I should have put a 4 up here instead. So 29 divided by 7 goes in 4 times. My second step is to multiply. 7 times 4 gives me 28. My third step is to subtract. My fourth step again is to check, and 1 is less than 7, so I'm okay. I'm going to go to my next step, which is to bring down the next number. Now I'm asking myself, how many sets of 7 are there in 15? Well, 7 times 2 gives me 15. So I'm going to put a 2 up above, keeping everything in line. 7 multiplied by 2 gives me 14. I subtract, I get 1. I perform my check. 1 is less than 7, so I'm okay. And I'm going to bring down my next number, which is an 8. Now I'm going to ask myself again, because I'm starting again, how many sets of 7 are there in 18? Well, there are 2 again, and then I'm going to multiply. 7 times 2 is 14. Subtract, I get 4. And there's nothing I can bring down, so I'm done. So my final answer to this is 422 with a remainder of 4. Now that we have the correct answer, how about if you take a moment and check this by multiplication and addition, pause this, check it by multiplication and addition yourself, and then turn this back on again and watch quickly as I go through and do this. Okay, hopefully you've been able to go through and check your answer by multiplication and addition. I'm going to go 422 times 7. Once again, I'm going to do this the traditional algorithm method. You may choose to do it another method that we talked about earlier. So as I go through and do this, 7 times 2 gives me 14. I put down the 4, I regroup the 1. 7 times 2 again gives me another 14, plus the 1 gives me 15. I put down the 5, I regroup the 1. 7 times 4 gives me 28, plus 1 gives me 29. So I get 2,954, and then I need to add that remainder of 4, which gives me that final answer of 2,958. So yes, I do have the correct answer. Here's a problem with a 2-digit divisor, and it works exactly the same way, but let me go through this particular problem. I have 36,448 divided by 12. And the very first step I'm going to say is I'm going to ask myself, how many sets of 12 are there in 3? Well, there aren't any. I can't divide 3 by 12. So now I need to say, how many sets of 12 are there in 36? Well, if I go through my multiples of 12, 12, 24, 36, I would see that 12 can go into 36 3 times. So I am going to put a 3 up top. Now this is where it's very important. That 3 needs to go above the 6. It can't go above the 3 because I'm asking how many sets of 12 are there in 36. And this is a common mistake that sometimes people make, is put that 3 in the wrong location. Now I'm going to go through and I'm going to multiply. 12 times 3 gives me 36. I'm going to write that down and I'm going to subtract. When I subtract, 36 subtract 36 gives me 0. And when I check, 0 is less than my divisor 12, so I can go on. I'm going to bring down the next number. The next number is 4. Now I'm asking myself, how many sets of 12 are there in 4? Well, there's none. I can't do anything with that. 4 divided by 12 does not work. If you have 4 things and you're going to put them into 12 different groups, you can't. So this is very important. I am going to have to put a 0 up top because 12 goes into 4 0 times. Now I'm going to go through and I'm going to multiply again just because I want to continue with the same pattern. 12 times 0 is 0. I subtract. I get 4. And now, once again, I'm going to bring down that next number. Now, before I do that, I do want to do my check. Is 4 less than 12? It is. So, yes, I can go ahead and do my next step. I'm going to bring down that other 4. And now I'm saying to myself, how many sets of 12 are there in 44? Well, if I go through 12, 24, 36, 48, 48 is too much. So once again, this is going to be a 3. 12 goes into 44 3 times. 12 times 3 is 36. That was my multiplication. Now I'm going to subtract. 44 subtract 36. Let's see, I can't take 6 from 4, so I regroup. That becomes a 3, that becomes a 14. 14 subtract 6 gives me 8. I check and make sure that works. If 8 is 8 less than 12, yes it is, I'm A-OK. I'm going to bring down my last number, which is an 8. And I'm going to ask myself, how many sets of 12 are there in 88? So I go through all my 12s, and when I go through my multiples of 12, I will see that 12 times 7 does give me a number pretty close to 88. 12 times 7 is 84. So I'm going to multiply. 12 times 7 gives me 84. I subtract, I get 4. I'm checking. 4 once again is less than 12, so I'm good. The answer to this is 3,037 with a remainder of 4. Once again, I find that a number of reasons people have difficulty, or one of the reasons people have difficulty sometimes with these, is just because of the math facts. So sometimes if I have something like that, I even start off by first of all just writing down what are all the multiples of 12. And I just go through and I use that because I know I'm going to need to use that information as I go through this particular problem. And if you find that helpful, that might be something that you might want to do. Once again, you could certainly go through and check this by multiplication and addition. If you were taking a test or a quiz, for sure you would want to do that. So just make sure that you're able to do that. I'm going to finish off this particular video by giving you 2 problems that I'd like you to do on your own. Here's the first one, 6,348 divided by 9. So what I'd like you to do is do this problem on your own. You can pause the video and then turn it back on again and watch me as I go through and do it. Okay, hopefully you've been able to go through and do this particular problem. As I go through and do this particular problem, the very first thing I'm going to do is I'm going to say to myself, how many sets of 9 are there in 6? Well, there aren't any sets of 9 in 6, so I need to go to both numbers. And I say, how many sets of 9 are there in 63? Going through my multiples of 9, I will see that 9 times 7 does give me 63. So I'm going to put that 7 right up above the 3 and now go through and multiply. 9 times 7 gives me 63. I subtract, I get 0. When I perform my check, 0 is less than 9, so I'm good. I'm going to go on to my bring down. I'm going to bring down my next number, which is a 4. Now I'm asking myself, how many sets of 9 are there in 4? Well, there aren't any. So I'm going to have to put a 0 up here, and then I'm going to multiply. 9 times 0 gives me 0. I subtract, I get 4. I perform my check. 4 is less than 9, so I'm okay. And I'm going to bring down my next number, which is my last number. And I'm going to ask myself, how many sets of 9 are there in 48? As I go through the multiples of 9, 9, 18, 27, 36, 45, 9 times 5 is 45, so 9 goes into 48 5 times, and now I'm going to multiply. 9 times 5 is that 45. I subtract, I get 3. I check and make sure, yes, 3 is less than 9, so I'm good, and I'm also done. My final answer to this is 705 with a remainder of 3. Here's the last problem for you to do, and once again, if you'd like to write this problem down, do it yourself, and then watch me after you do it, that might be a great way to go through and do that. Okay, so I'm going to go through and do this problem, 32,460 divided by 15. And I have the number 15. I need to ask myself, how many sets of 15 are there in 3? Well, I can't do that. So instead of saying how many sets of 15 are there in 3, I'm going to ask myself, how many sets of 15 are there in 32? Well, if I go through the multiples of 15, 15, 30, it would be a 2, because 32 divided by 15 would give me 2 sets. Now I'm going to go through and I'm going to multiply. 15 times 2 gives me 30. And I'm going to subtract, and I'm going to get 2. I'm going to check, is 2 less than 15? Yes, it is, so I'm good. I'm going to go on to my next step, which is to bring down a 4. And now I'm going to ask myself, how many sets of 15 are there in 24? Well, once again, as I go through my multiples of 15, 15, 30, so the 30 is too high, so this just needs to be a 1. And then I'm going to multiply. 15 times 1 gives me 15. I'm going to subtract. 24 subtract 15 gives me 9. Perform my check. 9 is less than 15, so I'm good to bring down my next number, and I get a 6. And now I need to ask myself, how many sets of 15 are there in 96? Once again, this might have been something that would have been easier had I started off just going through and having all the multiples of 15. 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, so forth. As I go through that, I would eventually find out that 15 times 6 was equal to 90. So that's the closest to 96. So 15 goes into 96 6 times. 15 times 6 gives me 90, and now I'm going to go through and I'm going to subtract. When I subtract, I get 6. I'm going to perform my check. Yes, 6 is less than 15, so I'm going to bring down that last number, which is a 0. Don't forget, you do need to bring down the last number. Sometimes people stop at that because it's a 0 there. Now I'm going to ask myself, 15 goes into 60 how many times? Well, if I had finished this off before, I would have known that 15 times 4 does give me 60. So I'm going to put a 4 here and go through and do my multiplication. 15 times 4 gives me 60. And in this case, I end up with a remainder of 0. So the final answer to this is 2,164 with a remainder of 0. I really don't even have to put in the remainder 0, but just to be clear, I'll put that in. Once again, when you get done with this, it would probably be a good idea for you to go through and multiply 2,164 times 15 just to make positive sure that you do have the correct answer. And when you go through and do that, you should get the 32,460. Being able to divide with problems like these will be very important as you continue in this course and in courses that come after this. Later on in this course, we will expand on this idea as we divide with decimals. Please be sure to let me know how I can help you as you work through the material on this topic. Thank you.